Hello everyone and very welcome to this video. This video is intended for the mow217 class of 2023 and my name is Dr. Lucas du Plessis. I'm a senior lecturer in the Department of Mechanical and Aeronautical Engineering at the University of Pretoria. So what you see on the screen is just the write-up regarding the practicum 5 that we are currently discussing. The arrangements are as follows. The practicum will be conducted under test conditions and there will be invigilators present. You are not allowed to bring any source of information, be it printed or digital, into the venue. You're also not allowed to log out of the computer and log back in with your personal login details. So when you arrive in the computer lab, the computers will be logged in already and you can immediately start working. So you're also not allowed to log into ClickUp. If you do, you will be asked to leave the venue and you will get 0 for the practicum. Okay, so in order to watch the video, you obviously need some earphones with either a 3.5mm jack or a USB connection. Bluetooth earphones will not work. And you will have access to the K drive of your computer, which will have the following: a PDF file of a dimensionless detailed mechanical drawing of a single mechanical component. The dimensionless detailed mechanical drawing will only contain the views of the specific component. In other words, no dimensions. It will either be a top view, front view, section views, detail views, etc. Apart from that single PDF dimensionless drawing, you will have step files of the component and relative subassembly. And you'll have access to this WebM file, video file, containing the necessary background information, such as how does the component fit into the Shigley-Haller mechanical assembly, as well as the relevant subassembly. If applicable, I will tell you more about the raw material that will be used to manufacture the component, as well as any other relevant manufacturing information pertaining to the component. You will also have access to the design literature folder on ClickUp. Okay, so then during the practicum you will receive a set of OCR forms. Please fill in the following on each and every page of the OCR form. I mean, each page has 2 OCR forms, one on the front and one on the back, and then there's a second page with a single OCR form. The back of that form is empty. So you will have 2 pages with 3 OCR forms. At the top of each OCR form, you need to fill in your student number as well as the assessment ID that is shown here. Now, there are 3 OCR forms with the views presented on the dimensionless PDF drawing. You are expected to dimension and add GD&T to the views on the OCR form as if you had the dimensionless PDF in front of you. Right? The dimensionless PDF drawing of the component is now spread over 3 OCR forms, and you need to dimension those views as if they are present on a single sheet of paper. So don't add the same dimension or same feature, don't dimension the same feature twice on different views. So in order to get the nominal value of a dimension of the part that we are now creating a detailed drawing for, you need to import the step file into FreeCAD and use the manipulator workbench to capture the measurement. You need to decide which dimensions to add to which views on the OCR form. So there's also a YouTube video with a simple demonstration on how to take measurements using the manipulator workbench, and you're also by this time well familiar with the workbench. you've used it now. This is the third practicum, and you've used it also in the semester test. So you also need to add tolerances to the dimensions, and you need to decide on your own what the magnitude of the tolerances should be. And lastly, and very importantly, you need to decide if, where and how to add GD&T to the views on the OCR form. What you see on the screen now is the Schick de Holler gearbox, and you are by this time well familiar with this gearbox. We've been looking at it for during practicums 4, 5, as well as during the semester test. So the specific sub-assembly that we will focus on in today's practicum is the drive shaft. That's the sub-assembly onto which this motor is connected. So if I can just zoom in a little bit and orientate the gearbox slightly. So specifically what we're going to look at is the connection between the pinion gear and the drive shaft. So it's basically the drive shaft, the pinion gear, and then this lock ring. That's the sub-assembly that we are considering now, and you will be dimensioning this lock ring. Okay, so I've got another view of only those components, the shaft, the pinion gear, and this lock ring. Okay, and then what assembles or secures the lock ring as well as the pinion onto the shaft is the shoulder bolt. And you can see it runs all the way through, and then here at the end there is a set screw or a grub screw that ensures that the shoulder bolt won't fall out. So what you should take note of in this sub-assembly drawing is where there are clearances. Okay, so there are, and you can take measurements for the shaft diameter and the hole diameters to see if there is any clearance there. But looking at this view, you can clearly see there is a nice big clearance between the shoulder on the shaft and the end of the pinion gear, which is this light blue color. Okay, and then there's also clearance between this lock ring and the face of the pinion gear. So there's also a nice big clearance there. So just to then also explain how this lock ring and shoulder bolt actually secures everything in position. So let's just, the lock ring will have a close fit between the shoulder bolt, or for the shoulder bolt, this portion of the shank of the shoulder bolt, and then on the other end of the lock ring, this hole is tapped M5 thread, and then as I said earlier, the set screw or grub screw, this little screw over here, secures the shoulder bolt from coming loose. Okay, so this is what the shoulder bolts look like, or a shoulder bolt. The specific one that we are using, the dimensions are presented over here. So the diameter is 6, the length is 20. There's the tolerance F9, as well as all the other relevant dimensions. Okay, so in terms of material, this lock ring will be manufactured from steel. The reason why I've selected to use this heavier material or relative heavy material is because I want this screw thread, this M5 screw thread, to last a long time. As you know, the assembly will be reassembled year after year, and so I don't want that to get damaged. Okay, then what you will also note is that I've designed the lock ring to be assembled either way. There's not a, this face can be next to the gear, or as shown here, this face over here can be immediately adjacent to the gear teeth. Okay, so what I've also done is I've added this chamfer over there on both sides, and the reason for that is depending on the tolerance that you select here, there will be a fillet on the inside here. It's not shown in this CAD view, but there will be a fillet, and I just want to make sure that there's no interference there. Right, so yeah, what's important for the lock ring is obviously the fit between the pinion gear and the lock ring, that fit, and then the location and fit for the shoulder bolt, this top portion of the shoulder bolt hole, the countersunk hole. So there's a diameter where the shank of the shoulder bolt needs to align. That fit is important. And then also the location of the screw thread is also important, because otherwise you won't be able to assemble this part. Okay, so I've designed clearances so please measure all for example, that diameter on the lock ring where the shank goes through. Measure the diameter of where the lock ring interfaces with the pinion gear, and make sure you can measure then, of course, the pinion gear to see what the clearances are that I've allowed for the nominal sizes. And then you obviously, on top of the clearances, you now need to select your tolerances and geometric dimensions and tolerancing symbols that you want to specify. So I hope you enjoy and that you learn something from this practicum. Thank you very much for watching.